Alright guys, so sticking with our triangles theme, we're going to talk about congruence in triangles today. So, first off, we need to define what congruent figures are. Congruent figures are when all parts of one figure are congruent to the corresponding parts, meaning the parts that match up, so the corresponding parts of another figure. So all parts of one figure are congruent to the corresponding parts of another figure. So in this case, you can see we have all of those pieces that match up in the diagram. So write a congruent statement for the triangles. Identify all pairs of congruent corresponding parts. So looking at the diagram on the left, we want to see what they match up with. So angle A, we have a right angle there. So angle A matches up with angle F, which also has a right angle. So angle A is congruent to angle F. Angle B has a single arc. Angle G does as well. Angle C has the double arc. Angle H does as well. Corresponding sides are a little bit trickier, only because the order does matter here. So we're going from A to B in the first triangle. Now I want you to notice at point A we have the right angle, and then at B we have the single arc. So if I look at the other triangle, this GF or FG has the same double tick, but point F has the right angle, so that's where I need to start, since that's where we started in the first one. So it would go in the order FG. BC has the triple ticks. B has one arc, so that's where we need to start. Look over at the other picture. The triple ticks are along GH, and the single arc is at G, so that's where we start. All right, and then CA, we're going from the double arc to the right angle on the single tick side. So double arc to the right angle would be HF. Notice I'm putting the bar on top since we're using the congruent symbol there. So our congruent statement, this is a new term and it's a term that you need to know. Our congruent statement is when we match up all of those, then we can say that two triangles are congruent. So if I go in the order triangle A, B, C, order matters again, I'm going to say is congruent to triangle, and then A we said matches up with F, B matches up with G, and C matches up with H. You could have listed that as triangle CAB, that's the third angle, the first angle, and the second angle, and then you would have listed it as HFG to go in the same order. Just make sure the pieces match up. Okay, so in the diagram, triangle EFG is congruent to triangle OPQ. Complete the statements. Okay, so we're looking for EF is congruent to, so two places you can look. You can look in the picture and see where it looks like EF matches up, or you can go up here and say, okay, EF is the first two letters there, OP is the first two letters there. So EF matches up with OP, and we see that in the picture as well. Angle P is congruent to, and so again, you can look in the picture, or you can look up top, and we see that it matches up with angle F. Angle G is congruent to, so whichever you prefer, but it matches up with angle Q. Now don't get tricked on this next one. This one doesn't say angle O is congruent to. It says the measure of angle O equals. Anytime you see that measure, we're asking for a number. So I want to know the degree measure. And if I look at angle O, I see that it's congruent to angle E, and angle E measures 110 degrees. So angle O also measures 110 degrees. This next one as well says QO, but there's no bar on top of it, and I have an equal sign. That tells me I'm looking for a value. So QO matches up with GE in the left triangle, so it's 7 kilometers. Now this last one is our new congruent statement, triangle GFE. So we're switching up the order, but if I go GFE, I see that that matches up with QPO. So I'm going to put triangle QPO. If you look back up at your congruent statement, we just flipped that order. GFE is third, second, first. QPO is third, second, first as well. So 2 places you can check that. Okay, so another theorem for you. Third angles theorem says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are also congruent. So we know both those triangles add up to 180, so we know that if 2 of their angles are the same, then that third one has to be the same as well. So here's how we can use this. Find the measure of angle V. Okay, so I see these arc marks. So right away I can say that this angle over here is also 66 degrees. And then I see vertical angles coming up right here. So I know that this is also 44 degrees, which means that I know that if I did 66 plus 44 from this triangle on the left, and I get 110 degrees, then I can solve that and know that my third angle has to be 180 minus 110, and that gives me 70 degrees. So this is 70 degrees, which means by the third angles theorem, this also has to be 70 degrees. So the measure of angle V is 70 degrees. Okay, properties of congruent triangles. So we've seen reflexive, symmetric, and transitive a lot. So now we're using it with triangles. So reflexive tells us something is congruent to itself. So triangle ABC is congruent to triangle ABC. It's congruent to itself. Symmetric tells us to flip them around. So if we know that triangle ABC is congruent to triangle DEF, then we also know that triangle DEF is congruent to triangle ABC. Transitive property, remember, tells us if the first one is congruent to the second one and the second one is congruent to the third one, then we can jump straight from first to third, and that's what it says here. With triangle ABC is congruent to triangle DEF. Triangle DEF is congruent to triangle JKL, so triangle ABC is congruent to triangle JKL. And we are not going to do this summary page, so I will see you all in class. If you have any questions, feel free to contact me. Come see me before school, after school, during broad quiz time. Have a great day.